All right, welcome to my very first lecture on Chapter 1, which is on counting. Here's going to be a quick example. Okay, so here's a quick example. There are 4 choices for a main course and 5 choices for a drink. And here the question is, how many course drink combos are possible? So this is on counting. So if I was to write down an option, so here there was main course and they could have choice 1, they could have choice 2, they could have choice 3, or they could have choice 4. And then for drink, they could have A, B, C, D, or E. This main area, which I'm not going to entirely fill in, this is going to be A, 1, all the way through E, 4. If we count this, these are the total number of combos. And I think it won't be too hard to believe that there are going to be 4 times 5 outcomes. And in fact, that's the answer, is going to be the 4 times the 5, which gives us the 20. Okay. So that's an example of what we call the general counting principle. If 2 events A and B occur in N sub A and N sub B ways, then A and B occur in A times B ways together. And that's an example of this general counting principle, which is what we just discussed. Okay. Let me give you another example here. Okay. Okay, so in this example, we're going to make a password. So, in how many ways can you make a 4-digit password? So we all have these, whether they're on our cell phone or on our email account, but these are strictly comprised of digits. Okay. So there are going to be 4 digits. So here's the first digit, here's the second digit, there's the third digit, and here's the fourth digit. So how many ways can we enter a digit for the first digit that we enter? Well, it has to be a number between 0 and 9. There's 10 of those. Counting principle says multiply times the number of ways that we can enter a second digit. There's again 10. For the third, also 10. And for the fourth, also 10. Now let me change things up with you here. And I'm going to change things just slightly. Okay, so the question is going to be very similar. In how many ways can we make a 4-digit password but no digit can be repeated? Well, it's again going to be very similar to the last answer, but we're just going to modify it slightly. And remember, the counting principle says we're going to multiply all these outcomes together. So for the first digit, we can do this in 10 ways. And when we get to the second digit, we chose one of the 10 digits for the first one. So there's only 9 that we can put down for the second. When we get to the third digit, well, we chose one for the first digit and one for the second, so there's now only 8. And by the time we get to the fourth digit, 3 digits have already been chosen. So that's going to be a 7. So that's 10 times 9 times 8 times 7. That's how many ways we can make a 4-digit password with none repeated. I'd like to do something here. In fact, I'd like to write this as 10 times 9 times 8 times 7. But now I'm going to just write the rest of this down, times 6 times 5 times 4 times 3 times 2 times 1. Okay? And I'm going to divide by 6 times 5 times 4 times 3 times 2 times 1. And the reason I'm going to write like this is because these two cancel each other out. But there's common mathematical notation for the numerator and the denominator. The notation that we have is just this. Is that this is going to be 10 factorial divided by 6 factorial. And this is an example of what's called a permutation. Okay. Now, first let's just back up and discuss these things in a little bit more detail. Okay, so first, I did like this factorial thing. N factorial. This is defined to be as n times n minus 1. And you multiply every digit all the way down to 1. Okay, so that last one's a 1. So for example, if I was to do 4 factorial, that will be 4 times 3 times 2 times 1, and that's 24. Okay. And now I want to do this permutation. So I want to emphasize that in a permutation, there was an order to it, a first, second, third. So I first note that order matters, and it depends on two things. N here, and here this is going to be the number of possible objects. Objects that can be selected. Okay. And K, that's going to be the number of objects placed. In order. Then it's written like this: n permute k is going to be n factorial divided by k factorial. So in our example, we needed to place, there were 10 possible objects and we had 4 slots, so 10 factorial over 4 factorial is how we got the answer in the last one. Okay. 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 So let's just take a second here, and I'm going to now just give a quick example of permutations. So here's going to be a question. I already have the example written. So how many ways can we reorder the letters W, H, Y? So just as an example of a reordering, 1 might be HWY, but we could write out all the different ones. I could do HWY, I could do HYW, I could do WHY. That is a reordering, the object itself. I can do WYH. I can do YHW. Okay, 1, 2, 3, 4, 5, and there's one more, which would be YWH. Those are all possible different reorderings. 6. There are 6 ways to do it, but there's another way to do it using the counting principle. There are 3 objects, and I need to place it into a first, a second, and a third. Okay, so first, second, third. Well, for the first one, no letters have been selected. There's 3 of them. Then for the second letter, one of them is now selected, so there's only 2. Then for the last one, only the last letter remains. This would be 3 factorial would be our answer here. Okay. Now, let me give you one more example. They're a quality control engineer. Must test 6 different electric parts. Okay. Now, if 2 are made by the same company, in how many ways can that company's part be tested back to back? And here's going to be my answer. My answer is that there are 5 distinct parts. So the number of ways to test 5 distinct parts is going to be the first, second, third, fourth, and then there's going to be the 5th. And this is going to be, well, for the first, there's going to be 5 different companies that we can select by. Then there's going to be 4, then there's going to be 3, then there's going to be 2, and then there's going to be 1. Now, somewhere in here, there's going to be the company in which there is 2 parts that they need to test back to back. Let's suppose that's here. So there's going to be part A and there's going to be part B. So that is going to be your 6. There's going to be 3 here and 1 here gives you 4. And then on the 4th spot, there's A and B. Now we can reorder A and B by permuting A and B. So for example, B could be first, then A, or A could be first, then B. So it seems like there's 5 factorial ways to select a part, to select a company, then 2 different ways, 2 factorial ways to reorder A or B. And that's how many different ways there are. Now, here's another example. Now, a company must select 3 employees from a team of 5 to work overtime. In how many ways can this be done? So let's say the employees have names, and let me give them a name right now. So John, Luke, Mary, Aaron, and Ryan. Okay. When we select the employee, all that we need are 3 of them. So for example, we might see that there's a first, second, third. And your first, second, third could be John, Mary, and Aaron. But it actually didn't matter that you were counting order. So in this one, if you were to do a permutation, this would not be the same as this. Aaron, Mary, or John. A permutation would be counting those 2 are different. If you use a permutation. Okay? But it's the same because it doesn't matter whether you're selected first, second, or third, you're still working over time. So we need to divide by the number of ways that we would double count. So this is double counting. And a double counting would only occur if we could, for example, reorder the way in which we get John, Mary, or Aaron, permute first, second, or third. And there's 3 objects to be permuted. So 3 factorial ways to permute or double count. Okay, let me get a new slide here. Hence, we want to remove order. Okay, and if we remove order, well, that means we divide by the number of ways to rearrange or double count the objects. And that's 3 factorial because there's 3 positions. Okay, so the answer is, well, we have 5 employees. If we were to do a permutation, we'd permute 3 of them, but we need to remove order, so we divide by 3 factorial. Okay. This is known as a combination. Okay. Okay, and this is written as, there's 2 different ways of writing this. There's going to be n choose k or n c k are the common ways. And let me give you this formula. So for combination. Okay, and in a combination, order does not matter. Okay, so n choose k, that's going to be n factorial divided by k factorial times n minus k factorial. Okay, and that is the formula for combination. Okay, so with that, I'm going to give you one last example on counting. Okay, and this is going to be your example. A coin is tossed 3 times. What is the probability of exactly 2 heads? Now, probability, I hope you'll accept this definition, is the number of ways to get 2 heads divided by the total number of outcomes. Now the total number of outcomes, that's in the denominator. Well, there's a first coin cost, there's a second, and there's a third. For each toss of a coin, there's 2 outcomes. So 2 times 2 times 2. So we have 8 in the denominator. Now, let's focus on the numerator. So we have the number of ways to get 2 heads. Now I could get a head. Here's going to be an example. I could get a head and then a second head, and I want exactly 2 heads, so the last one has to be tails. You might be thinking, oh, that's first, second, third. However, if I was to do first, second, third, let me do one thing here, and let me erase that and put in a color of a blue. Excuse me. Head. That's exactly the same outcome as this. Heads, heads, tails. Now, that would be, if I was to do a permutation, I'd distinguish the blue from the black heads. I don't care about distinguishing those 2 outcomes. So in essence, the order of the heads does not matter. I mean, after all, I don't care whether it's the first coin lands heads or the third coin lands heads, so long as only 2 of the 3 tosses land on heads. So this indicates to me I should use a combination and not a permutation. If you were to write down a permutation, you'd have the wrong answer, and you'd have to remember to divide by the number of ways to reorder the heads, which is 2 factorial, or 2. Okay, so there are 3 tosses of the coins, and I need to choose 2 of them to be heads. Another way of writing that you'll see me do is 3 choose 2 like that. That's going to be 3 factorial over 2 factorial times minus 1 factorial. And when you work this number out, you're going to get 3. So finally, your answer is going to be probability of 2 heads. That's going to be 3 ace. Okay, if you're tossing a fair coin. All right, well, thank you for listening today. That's all that I have.